Hello and welcome everyone, and in this video we are going to understand different types of load that are going to come on steel structures. And to resist these external loads, how do we design our structural members? What are the design philosophies behind any principle of design we are going to apply in it? So let us start with discussing about the loads. So actually there are only three categories of loads. The first one is the dead load, and it is represented by capital DL, and then there is live load represented by capital LL, and live load is also known as imposed load, and dead load is also known as self weight. The third category is the environmental loads, and there are a list of loads that comes under the heading of environmental loads. What is dead load? Dead load is due to gravity, the self weight of the structure, and the direction of dead load is in the direction of gravity. So we can very easily calculate the dead load of the structure from IS 875. IS 875 deals with different types of load, and IS 875 has been categorized into almost 4 or 5 parts. So the part 1 of IS 875 deals with the calculation of dead load, and when dead load is not known before the design, so we assume and later on we check it with this code also and the site condition also. The next type of load is the live load, and live load is also known as imposed load. Basically given in the Indian Standard Code IS 875, and the part 4 deals with the calculation of live load. And live loads are those loads which may change in position as well as even in magnitude, like those loads which are keep on moving, like furnitures, equipments, or even occupants. So we do some reduction also in live load in case of residential buildings, and this is the percentage reduction of live loads on different floors above the member under consideration, and this depends on the number of floors. So this is used in the designs of high-rise buildings. Okay, one more type of load which comes under the category of live load is the impact load. Now impact load is a very dynamic type of load, because a dead load is a static load, okay, whereas live load is a dynamic load. The position as well as magnitude of load will change. An impact load is a load which is applied suddenly, or the load is in motion, like automobiles moving on the bridges and the lifts of the building, or the industrial cranes moving. Few more types of load which are environmental loads, and under environmental loads only the earth pressure, water current force, thermal loads can also be considered. Earth pressure is those loads are mainly used for underground structures such as basement, retaining walls. The another type is water current force. Water current forces are mainly used for piers and abutments as well as offshore structures. And thermal loads are due to the temperature variation in those structure in which in the daytime the temperature is very high, whereas in the night time the temperature is very less. So due to this there may be up to 25% of live load in bridges and trusses. Okay, and the very important type of environmental load is the wind load, and this is very important: wind load and earthquake load. So these are the two type of very important loading that comes under the category of environmental load. You must remember, when we do the load combination, we never add these two loads or subtract these two load together. Either we have to use wind load or either we have to use earthquake load. The both wind load and earthquake load never act simultaneously. Okay, so the wind load is very important when we have to calculate the pressure, suction and uplift forces on the structure. Calculation of wind load becomes very important in case of high-rise buildings, because the wind speed increases with height, and the calculation of wind pressure at height Z above mean ground level. Mean ground level is also written as MGL, and this wind pressure is P is equal to 0.6 Vz square. P is the wind pressure and the unit of wind pressure is Newton per meter square. Vz is the speed of wind. How do we calculate the velocity of wind Vz? So Vz is calculated here and it is written, the formula is also Vz is equal to Vb times K1 into K2 into K3. See, all these formulas are taken from IS code IS 875 only, and this is maybe part 2 or part 3 maybe, where K1 is the probability or risk factor, K2 is the terrain factor, K3 is the topography factor, and all these three values are also listed in the IS code in a tabular manner for different places in different situations. Vb is the basic design speed of wind, and for the entire country India, it has been divided into different zones, and for different zones there are different speed of different cities, and zones are laid down in that map as well as in the table. Now when you have Vb, K1 and K2 and K3, you can very easily calculate design wind speed. So Vz is equal to Vb into K1 into K2 into K3. When we get the wind pressure, how do we calculate the wind load? So this wind force is the wind load, okay, and wind load is calculated as F is equal to Cf into Ae into Pz. Pz we have already calculated is equal to 0.6 Vz square. Okay, A is the exposed area in the windward side of the building. Okay, this is very easy to calculate and we have to do it in meter square. Cf is the force coefficient for buildings and it depends on the shape of a structure. So this is also given, and when we multiplied Cf, Ae and Pz, we get the wind load. One numerical problem also on wind load calculation, so we will do it in the next video. Now, what are the design philosophy basically behind the design of any structural member? There are three requirements. Either you do RCC construction or steel construction. First one is the strength or integrity, whatever you say. And the second one is the serviceability. Third one is the durability. Now, integrity means the strength. And strength means its constituent parts should constitute a stable and robust structure under normal loadings, and columns must be anchored in two directions at right angles. Means the structure is entirely having sufficient strength so that the structure may not get loosed or failed. Okay, and then comes the stability. Stability means the structure do not overturn or slide down. Okay, the structure remains stable. And the third requirement is the durability. Durability means when it comes to the serviceable life, it is not much seriously damaged under serviceable condition. And even in the under accidental load, it doesn't get damaged very seriously. Structure is very durable. So these three requirements are very important. Like in the RCC design, we also use the same design methodology in steel also. So there are three important methods: working stress method, WSM. Second one is the ultimate load method, or also known as plastic method. The third one is the limit state method. So let us discuss all these three methods one by one, and we will mainly focus to limit state method because that is what the entire IS 800 code is based on. But for an understanding, we must have what is the design principles behind those techniques. So the first one is the WSM, and WSM is an elastic method of design. Okay, so we do not use the plastic region of the stress strain curve, and we fix up to ourselves up to the elastic limit, and we do not go beyond it. Okay, and it is based on the concept that maximum probable stress due to the applied load must be less than the permissible stresses. Okay, now what is permissible stresses? Permissible stresses is the capacity of the material, and the load should be less than the capacity. The external load which is going to come on this structure should be less than this capacity. Okay, and now how do we calculate this capacity? This is the permissible stress, and permissible stress is equal to material strength, which is the yield strength, divided by factor of safety. यील्ड स्ट्रेंथ को फैक्टर ऑफ सेफ्टी से डिवाइड कीजिए, परमिसिबल स्ट्रेस मिल जाता है, और उस परमिसिबल स्ट्रेस से कम होनी चाहिए लोडिंग जो आप लगाने जा रहे हैं स्ट्रक्चर पे, तभी आपका स्ट्रक्चर सेफ रहेगा. And why do we use factor of safety? We know in case of it accounts for the overloading, secondary stresses, stress concentration, and different natural calamities are also considered in that. And factor of safety can be 1.5 or even 2.0, 2.5, even up to 5 also is considered in case of design of tanks or water retaining structures. So what is the disadvantage of working stress method is that we have only used the limited material capacity up to the elastic limit. So we have not fully exploited the reserve potential of the material in regard of strength. We have not used the entire stress strain curve of the material. Neither do we check for the overloading conditions in WSM. And of course, WSM do not accounts for the serviceable conditions. When there will be the crack development, when there is vibration, nothing is considered. Serviceability is not at all considered. And the WSM is an overestimate method. It is a traditional method where we do over designing, and in over designing the cost is also increased. So this is little uneconomical also. Okay, now we come to the plastic method, which is called ultimate load method. We design basically for the ultimate loads, and of course we do not check here also for the serviceability. So we use the entire plastic region of the stress strain curve in this design method, and we know that there is higher strength after elastic limit, and that strength is called reserve strength, which is used in plastic design method. And in plastic design method we assume the formation of hinges, and the structure is designed till the collapse load is reached. And what is this collapse load? Collapse load is the ultimate load which comes on the structure and which can form a mechanism. Okay, this is a frame. The formation of hinges has happened, and when we apply a load, there is a formation of mechanism. Now the structure can, on the 4 hinges actually basically, and what had happened, the mechanism has formed. Okay, this is the plastic analysis part, and I hope you must have studied this structure analysis courses. Due to formation of 4 hinges, what had happened, a mechanism has formed. This value of load, this is called collapse load. Okay, so for this value of collapse load we design, and there is excessive deformation at collapse, and design load is equal to working load multiplied by load factor. And at plastic stage, plastic information and infinite rotation, more P hinges, collapse of a structure, everything is written here. Since the actual loads are less than the design loads and the structure do not actually collapse, but what are the disadvantages? We only are designing at the ultimate loads and we are not checking for serviceability. Serviceability is very important. What happens? Sometimes a structure is safe under loadings, but if we have not checked for serviceability, what happens? Sometimes deflection is so much excessive that the structure do not remain serviceable at all. So we are not going to design a structure which is very high strength, but there are many deformation. अगर ये कमरे की छत अगर काफ़ी नीचे झुक जाए, भले ही वो टूटेगी नहीं क्योंकि उसकी स्ट्रेंथ बहुत ज़्यादा है, पर हम वैसे घर में रहना पसंद नहीं करेंगे. ठीक है, like the Leaning Tower of Pisa, it is a wonder of the world, but the strength of Leaning Tower of Pisa is very sufficient. Okay, it can take any load, but it is not a livable place. People will feel uncomfortable in such structures because the structure doesn't remain any more serviceable. So the limit state method comes now in the picture, and it checks for both strength as well as serviceability. So both the drawbacks are considered in this. And what is limit state? Limit state is an imaginary hypothetical state beyond which the structure is unable to function satisfactorily. So we design the structure in such a way that the structure never reaches that limit state. So there are two types of limit state of strength and limit state of serviceability. I hope these two type of strength you must have studied in RCC1. Now limit state of strength checks for different load carrying capacity like bending, torsion, shear, compression. Okay, these different four types of loading are considered in the limit state of strength, and limit state of serviceability laid down those limitations or conditions which has to be satisfied for the service load, not the ultimate load, like deflection criterias, vibrations, fire resistance, cracks, etc. are considered in limit state of serviceability. So this you must have understood in the even in RCC1 and RCC2 we mostly explain this method also very explicitly and very clearly. You can read from the literature also. And limit state of strength deals with the basically the different types of loadings and the failures associated with those loadings. Okay, and limit state of serviceability mainly deals with the deformations and deflections, okay, which may adversely affect the appearance or effective use of a structure or may cause improper functioning of equipment or services. So corrosion and durability, fire, cracks, vibration, everything comes in limit state of serviceability, and limit state of serviceability is not very difficult to understand. Basically, the most part of calculation comes under the heading of limit state of strength. So now let us discuss what are the two very important objectives of limit state method. First one is the structure do not become unfit for use, it remains serviceable. And the second thing is that structure do not reach the limit state during its entire lifetime. So what we do in the limit state method is that we consider the characteristic values of loads, okay, dead load, live load, environmental load. We include only the characteristic values of all these loads, okay. And characteristic load is of course the 95% probability of the chance that the load will not increase this percentage. And for the strength of material, we considered the characteristic strength of material used in the building, and we keep 5% probability that strength will not go less than this. तो हमने क्या किया, लोड के चांस को बढ़ा दिया 95% कि इससे ज़्यादा तो होगा नहीं, और स्ट्रेंथ का भी 5% ही रखा कि इससे तो कम होगा नहीं स्ट्रेंथ, ठीक है। स्ट्रेंथ 5% चांस है कि स्ट्रेंथ इससे कम हो जाए, और लोड 95% चांस है इससे ज़्यादा नहीं होगा. And then what we do, we apply partial safety factor on loads as well as the building material strength. And in the strength, we divide the characteristic strength by the partial safety factor. अब देखिए partial safety factor को रिप्रेजेंट कर रहे हैं गामा m से for the material and gamma f से for the loading, ठीक है. And we know partial safety factor gamma is always greater than 1, ठीक है. And when the strength of material, हमारी जो लोड कैरिंग कैपेसिटी है किसी हमारे स्टील की या कंक्रीट की, अगर हम डिवाइड कर देते हैं गामा एम से, देन वी गेट द डिज़ाइन स्ट्रेंथ, ओके. और जब भी हम कैरेक्टरिस्टिक स्ट्रेंथ को पार्शियल सेफ्टी फैक्टर फॉर मटेरियल से डिवाइड करेंगे तो स्ट्रेंथ और भी कम जाएगी, ठीक है. तो क्या हम कर रहे हैं, स्ट्रेंथ को कम कर रहे हैं. वेयर एज व्हाट वी डू हेयर, डिज़ाइन लोड इज इक्वल टू पार्शियल सेफ्टी फैक्टर फॉर लोड मल्टीप्लाइड बाई कैरेक्टरिस्टिक लोड. कैरेक्टरिस्टिक लोड जो है उसमें हमने मल्टीप्लाई कर दिया पार्शियल सेफ्टी फैक्टर फॉर लोड विच इज ग्रेटर देन 1. कैरेक्टरिस्टिक लोड को बढ़ाते जा रहे हैं और स्ट्रेंथ को कम करते जा रहे हैं. ये बहुत ही इंटेलिजेंट टेक्निक है लिमिट स्टेट मेथड की. इसमें हम क्या कर रहे हैं, बाहर से जो लोड आ रहा है उसे हम ओवर एस्टिमेट कर रहे हैं और अपनी स्ट्रेंथ, अपने स्ट्रक्चर की स्ट्रेंथ को हम कम लेकर के चल रहे हैं, कम आंक रहे हैं, ताकि जब बहुत ज़्यादा भी लोड आएगा ना, तब हमारे पास रिजर्व स्ट्रेंथ है, चिंता करने की बात नहीं है, वो भी रेजिस्ट हो जाएगा. तो बाई दैट we are designing a structure that it never reaches the limit state. So this is the basic design philosophy. सबसे पहले हमें जो है कैरेक्टरिस्टिक लोड लेना है और कैरेक्टरिस्टिक स्ट्रेंथ लेना है. ये क्या चीज़ें हैं मैंने बहुत ही अच्छे से एक्सप्लेन किया एक वीडियो में, आप देख सकते हैं. एंड देन वी कैलकुलेट द डिज़ाइन लोड एंड डिज़ाइन स्ट्रेंथ with the help of partial safety factor for materials and loads. Now in the IS code itself, partial safety factor for loads is given in a code itself, and we have discussed that also, and we have done all the load combination. All these 4 types of load combinations we have shown you in that video, and they all are multiplied by these partial safety factors in the limit state of strength and limit state of serviceability. This table I have already explained there. And then comes the design strength. As we have discussed, if SU is the characteristic strength, it is divided by gamma m to get the design strength of material. Strength of material को हम कम कर देते हैं, ठीक है. And gamma m, the partial safety factor for material, accounts for possibility of unfavorable variation of member sizes, material strength, and possibility of unfavorable reduction in member strength due to fabrication, tolerances, different things that comes under material strength parameters. Okay, so whatsoever we have discussed till now, it all completes the introduction to steel as a building material, and different types of steel sections, different types of loads, and different design philosophy. Basically the limit state is very important to understand. What are the assumptions behind limit state, and what is the basic design philosophy? Increasing the load, and then decreasing the material strength, and design strength will now resist the design load very easily. So I hope everything must be very clear to you. Now we will discuss in the coming videos few numericals, and then we will move to the connections. So till that, stay tuned, stay safe. Thank you. So till that, stay tuned, stay safe. Thank you.